Hi, I'm Jim Marr, and in this session we're going to take a look at calculating covariance. Now, covariance is simply a measure of how two variables move together, and the value ranges from minus infinity to positive infinity. Now, with that in mind, you can imagine that units of covariance are difficult to interpret. Now, covariance is positive when the two variables tend to be above or below their expected values at the same time. Now, for each observation, we're going to multiply each probability times the product of the two random variables' deviations from their means and then sum them. You probably look at that going, yeah, that sounds a little bit difficult, especially when you look at this gem of an equation right here. But luckily for you, your calculator can do all the heavy lifting, and I will demonstrate that for you in just a second. So what I'd want you to do is you might want to print out this page, write down this information here, because I'm going to be using this throughout our example. And really what we're doing is we're looking at calculating the covariance between the return on two stocks indicated below. And we just got 3 years, nothing really too egregious here. We have stock 1 and stock 2, okay? Now I'm gonna put a big star by this one here. You can enter these variables as either decimals or whole numbers. Just be consistent and know how to make that interpretation at the end, okay? So we have stock 1 and stock 2. All right, let's go ahead and look at this. When we're looking at the returns, we're going to probably jump right into our calculator here. I've got my emulator up on the screen. You want to do second clear. Let's go ahead and start that up. And then we're going to go, we're going to do it again anyway. So we're going to do second. And we're going to go down here to data, 7, our 7 key. All right, and then once again, I'm going to clear everything out, make sure we're good to go. And now we're going to enter our stream. Now, I choose to use whole numbers. I find it a lot easier to do that. And probably if you're taking a professional exam, the answer choices are probably going to be in whole numbers, in this case, probably rather than decimals. So whole numbers are a lot easier to work with. So we're just going to go with 5. We got to enter our data for our first series here of X returns. So we're going to do 5, enter, and then our down arrow. Now you see we jumped to the Y variable. So you got to be really careful here that you know you would do your X for the first observation, now the Y for the first observation, and that's simply going to be 7, enter. We're going to continue down now at our second observation, 2, and we're going to use our plus minus key here to indicate our -2, enter. And you can see we're going to continue to do this, 4 and negative, and then we're going to press our enter key and go down again. Now in our third observation, we have our 12, enter, down arrow, and our third observation for our Y variable, our stock 2, is going to be 18, and you're going to press enter there as well, okay? So now what we're going to do is we're going to look at actually making our calculations. So what we're going to do is now we're going to go into our second, and we're going to go to our stat mode, and that is key number 8, all right? So we're going to go there, and we can see you're going to keep pressing until the LIN appears, and that's linear regression. And we got there. We already see that on our screen in front of you. So luckily for us, we don't have to do any more work on the calculator here. And now we're going to look at the various statistics that are calculated. There's our number of paired observations. You see that was 3, right? We had 3 observations for stock 1 and 3 observations for stock 2. Our mean variable of our X was 5. So I think this is pretty neat how it does all these calculations for you. Our sample standard deviation of our X variable here is 7. And now we're going to continue on and look at our other variables here as well. Now we have our population standard deviation of our X variable. That's 5.71. And then we have our mean variable of our Y variable. And that is our 7. And then our sample standard deviation of the Y variable is 11. Our population standard deviation of our Y variable is 8.98. Our intercept of the regression line is shown here, which you don't need to be dealing with here. Our gradient of the regression line, and then our sample correlation coefficient is going to be a simple 1. Okay, so I think this is pretty neat how we can go through all these sample statistics here in order to see what is the relationship between stock 1 and stock 2. Okay. So now moving on how we're going to calculate our covariance, you can see here we're going to be using our 3 variables, our sample standard deviation of X, our sample standard deviation of the Y variable, and then our sample correlation coefficient. So what we want to do here is we want to go back. So let's go ahead and start scrolling till we get to our SX of 7. Okay, and now we're going to press our STO key. We want to store this in memory. So let's go STO and then 1. Okay, now we're going to cycle to our next variable we need, and there is our sample standard deviation of our Y variable. And part of the key here is knowing what you need to use. So it's our store key once again in 2. And then we got to cycle down to our correlation, which is 1. So we're going to store that in 3. And now our calculation is simply going to be SX times SY times our correlation coefficient. So how are we going to do that? Well, we're simply going to go over here to our recall button. So we're going to recall 1, and we're going to multiply that by our recall 2. Okay, and then we're going to multiply that by our recall 3. And you're going to see, what do we get? We get 77 in our window, right? So we're right on par here. So our covariance here is going to be 77. Now, like I said, I like to work in whole numbers. I think it makes it a lot easier to interpret too, and chances are any answer on a professional exam, once again, will be in a whole number. But if we needed to move it to a decimal, you actually would move it over a couple spaces here, and you would get 0.0077. So once again, how do you get really good with doing these calculations? It's all about practice. But I really like this one because it gives you a whole lot of other detail that also can help you make some interpretations on various kinds of data across, say, 2 stocks and over a number of years. So I think this is actually a pretty neat way of analyzing some data as well.